This video is about quadratic functions that are in standard form. We're going to find the important information so that we can graph our equation without using a calculator. So again, in earlier videos when we dealt with factored intercept form, we wanted to get our 2x-intercepts, our vertex, and our y-intercept. Then once we have our y-intercept and we graph it, we can find the mirror image of our y-intercept so that we have 5 coordinates so that we can make our graph as accurate as possible. So on this form, the parent function is y equals or f of x equals ax squared plus bx plus c. This is in standard form because it is going from the highest exponent to the lowest. Standard form also has no parentheses. That is very important to notice there are no parentheses. To find our x-intercepts, we need to put it into intercept form because we're not allowed to use our calculator on this. What that means is that we actually, in order to find our roots, again, in an earlier video, I explained that roots are another word for solutions, zeros, and x-intercepts. So if we put it into x-intercept form or to intercept or factored form, we can find our x-intercepts. So to find the roots, we have to find the roots by factoring and using the zero product property. I did not explain this in my earlier video. The zero product property is when you actually, I explained how to do it, but I did not explain the terminology for it. The zero product property is when you set both of your factors equal to 0 and figure out what values of x would make the factor 0. That's what zero product property is. It's the same information we were doing. And I also did not show a quick and easy way for it. I want to explain that a zero product property, to find the roots, you can actually, you change the sign and then you divide. You divide by the number attached to the x. And when we have some of those, if we have some of those, I will explain that further. Okay. So what we want to do to find our x-intercepts, again, the roots, we want to factor this. I'm going to use the MACAB method to factor trinomials. If you are not sure what MACAB is or you want to factor it your own way, you can factor any way you want to. If you want to see a video on MACAB, I have another video posted to explain the MACAB version of factoring. It's another way of saying the AC method. Alright, so what we want to do is when we factor, we always find our GCF. In this case, the smallest number is 1, and there's not an x in common to all of them, so our GCF is 1, which will not affect the problem. So when we go to what our A equals to this positive 1, the B equals the 2, and then the C equals the negative 8. MACAB is when we do MAC, we do AB. MACAB is when we do the multiply A and C, so 1 times negative 8 is negative 8, and AB is what adds to B. Our B is 2. So the chart represents what multiplies up to 8, so we have 1 and 8, and 2 and 4. Now we figure out which values will add to give us a 2. This is when we deal with our signs. So 1 plus 8, 1 minus 8, any way we put them together will never give us a 2, so we don't want those. 2 and 4, if we subtract the 2 and we add the 4, it will give us a positive 2. But we have to make sure MAC adds correctly. So MAC, negative 2 times 4 gives us a negative 8, so that's good. And negative 2 plus 4 gives us the 2. These are our values that we want to use. Now, because A is equal to 1, we do not have to use the box. We can go straight into our factors. What this will in turn become, it will be f of x equals. Since we did not have to use a box, we automatically go into our parentheses. We have x, because that's the letter we're using. We have minus 2, and then x, because that's our letter. Then we have plus 4. This is actually factored form of the original. Now that it's in factored or intercept form, we can find the two x-intercepts, our m and n. So what I was talking about earlier with the change the sign and divide, we change the sign on our 2, which is right now it's negative, so it becomes a positive, and we divide by the 1 in front of the x. So we have a positive 2 divided by 1. So m is equal to a positive 2. In this one, we change the sign on the positive 4 to become a negative, and then we divide by the 1 attached to the x. So that becomes a negative 4. So n equals negative 4. So our two x-intercepts are at 2, 0 and negative 4, 0. And again, you can always figure out, set this equal to 0 and solve. You would just add 2 and you'd have your value. This one you would subtract 4 and you would have your value. We're going to determine if it is a minimum or maximum. This always comes from our a value. The a value was a positive 1. So since a is equal to a positive, we know that it will open up and that we will have a minimum value. So it opens up and it will be a minimum. That will help us with our range. Now we need to find our axis symmetry and our vertex. Because we're not given the vertex, we need to find the axis symmetry first so that we can use that to substitute back in. Now in the intercept form, we had m plus n divided by 2. We wanted to find the midpoint between our two x-intercepts. That is still possible. You can still do that. However, not every quadratic is factorable. So if you don't have the x-intercepts, because sometimes a graph will not cross the x-axis. So if it doesn't cross the x-axis, you can't figure out the vertex from doing m plus n divided by 2. So this one is actually going to show you how you can always find it from standard form, even if it's not factorable, how to find your axis of symmetry. Because every quadratic will always have a vertex. They might not have x-intercepts. You can still obviously do m plus n divided by 2 because you do have x-intercepts, but I'm going to use this format to show you how to find the axis symmetry if it's not factorable. So we have negative b over 2a. So we still need to know what our a, b, and c are. So a from our original problem was 1, b was a 2, and c equals a negative 8. We need to know those so that we can plug them in. As always, it's x equals, because it is the x value of our vertex, x equals. We have negative b. I'm plugging in the b value, so I use parentheses. Divided by, we have a 2, and then we have our a. So since I'm plugging something, I'm using parentheses. So we have x equals, this is negative times 2 is negative 2, over 2 times 1 is 2. So in this case, our axis symmetry is x equals negative 1. And so if we do this, 2 plus negative 4 is negative 2. And if we do half of that, it gives us negative 1 as well. So it gives us the same axis of symmetry. But again, we want to know this one as well in case the problem is not factorable. Now that we have our axis symmetry, we can find the rest of our vertex. This is the same way we did it earlier. We have x. Now that we have our x, we need to find our y. The x of our vertex was the axis of symmetry, so we're going to plug in the axis of symmetry for our x into the original equation. We always plug it back to the original. So we have y equals x squared plus 2x minus 8. So everywhere we see an x, we're actually going to plug in the negative 1. Now, you always want to use parentheses when you substitute. So we have y equals, there's an x, I put parentheses, squared plus 2 parentheses minus 8. This goes back to function notation. Anywhere you see an x, we put parentheses. Now inside of the x, we put the negative 1. So inside the parentheses, we put the negative 1. Now we can actually plug this straight to our calculator, or you can simplify it. You want to make sure it is accurate, so you always want to double check it if you can in your calculator. Negative 1 squared is a positive 1, and then we have 2 times negative 1, which is negative 2. So now what we have is 1 minus 2, which is negative 1, minus 8 is negative 9. So our y value is actually equal to negative 9. So our vertex, the x that we plugged in, our input was negative 1, and the output was negative 9. So our vertex is negative 1, negative 9. When you have a quadratic function in standard form, it will automatically give you your y-intercept. Your y-intercept is actually going to always be 0, And then, no matter what, if you're in standard form, your C value will actually tell you your y-intercept of the original function. So our C value is actually at -8. So our y-intercept is 0, -8. Now, you can still plug in 0 to the original function and get your y-intercept. So 0 squared plus 2 times 0, so that's 0 plus 0 minus 8. So it still gives us a -8. So that doesn't change. Now, intercept form gave you your 2x intercepts. Standard form gives you your y-intercept. And remember, there are 4 coordinates we want. We want our 2x intercepts, our y-intercept, and our vertex. The 5th coordinate comes from the mirror, but we do that after we graph. So the intercept factor form gives you your 2x intercepts. Your standard form gives you your y-intercept. And in another video, we're going to have vertex form, which will give us our vertex. So each of the 3 forms for quadratics gives you part of the important information, part of the points that we need to graph. Now, domain is still, because it's a quadratic, it's still going to be written as open bracket, -infinity to +infinity, open bracket. Our range is still written the same way as well. We need to find our minimum or maximum value. Since it's a minimum, we have minimum value. Our minimum value was, again, the y value of our vertex. The y value of our vertex was -9. So when we write our range, we always go ahead and put the comma. It's opening up. Opening up means it has a positive infinity. Positive infinity is always on the right-hand side with an open bracket. Therefore, our value is what goes into the left-hand side because that's our minimum. Again, this is minimum, then our maximum. This will be a closed bracket because it is actually stopping at -9. In just a moment, we're going to do this again on another problem, but we're going to graph them as well. Okay, so we find our 2x intercepts, our vertex, and our y-intercept. When we graph it, we'll find the mirror of our y-intercept, but that's after we graph it. We find axis symmetry so that we can find our vertex. We must factor it and put it in factor intercept form so that we can find all of our pieces of information. So this next problem, we need to do the same. It's in standard form. It's ax squared plus bx plus c. So in this case, if you notice there's a negative out front, which we should not have, we need to factor the GCF. Our GCF in this case is a -1. So I'm going to rewrite this as negative parentheses. I'm going to divide everything by that negative because that is our GCF. We're going to have a positive x squared inside. We're going to have a positive 4x inside. We'll have a -5 inside. Now, because there are 3 terms left over, we look to see if we can do MACAB. So from inside the parentheses, we're going to do MACAB. Our A value is now equal to a +1. Our B value is equal to a +4, and our C value is equal to a -5. This is because it's inside the parentheses. Since A is now equal to a 1, we do not have to use the box in the end. We just have to do our MACAB. So our MAC is 1 times -5, and our AB is that +4. So the only thing that multiplies to 5 is 1 and 5. To get a +4, we have to subtract the 1 and add the 5. So make sure it maps correctly. This is a -1 times a +5 does give us the -5. This is -1 plus 5 does give us the +4. So this is good. And again, since A is 1, we do not use the box. We can go straight into our factored form. Our factored form is going to be negative parentheses. We use the letter x, and then we have the -1 from our MACAB. Parentheses, we use the letter x, and then we have the +5 from our MACAB. This is now factored form. F of x equals negative parentheses x minus 1, then x plus 5. Now, we use the information from here, like our opens, our max or min, our y-intercept. That actually comes from our original problem. Factor form is going to help us find our x-intercepts. That is the reason we do factored form. So our m value, again, go back to your parentheses. We change the sign so it becomes a +1 and divide by the 1 attached to the x. So +1. N equals we change the sign, that becomes a negative 5, and divide by the 1 attached to the x. So that becomes a negative 5. So our two x-intercepts are at 1, 0, and negative 5, 0. We want to find our vertex, but in order to do that, we have to find our axis of symmetry. Now, because these do have intercepts, we can use our m plus n divided by 2, but we want to make sure we understand how to find the axis of symmetry using the other format as well. So for our AOS, we do x equals negative b over 2a. So in this case, we have negative parentheses. Now, we always go back to the original. We only use this part for our x-intercepts. Now, everything else will come from our original. Negative b. Our original b was a negative 4. Divided by 2 times our original a was a negative 1. So we have a 4 divided by a negative 2. So our axis of symmetry is x equals 4 divided by negative 2 is a negative 2. Now that we have our axis of symmetry, we can go back and figure out our vertex, again using the original problem. So to find the rest of our vertex, we put, instead of f of x, I can put y equals negative, everywhere I see an x, I'm going to put parentheses. So parentheses squared minus 4 parentheses plus 5. Now I'm going to plug in anywhere I see the parentheses, I'm going to plug in that negative 2 because that was my x. Negative 2, negative 2. And what we do, you can plug this straight into your calculator, this part into the home screen so that you can actually just find that value. So I'm going to have negative parentheses, negative 2, close parentheses, squared, minus 4 parentheses, negative 2 parentheses, plus 5. Enter. I get a positive 9. So that means that our vertex, the y value of a vertex equal to a positive 9. So our vertex is at negative 2, comma, positive 9. Because again, the x comes from the axis symmetry. The y-intercept comes from, again, the y-intercept comes from 0, comma, your c value. If it's in standard form, it automatically comes from your c value. You can still plug in 0. So we have 0 squared and 4 times 0. So all of this right here is 0 plus 5. So again, that's why it comes from the c value, because if you plug in 0, you still are only left with that positive 5. Now again, from the original function, this one, a value, the original a value is a negative. So that means that it will open down. And because it opens down, that means that it's going to have a maximum. The value of our maximum, again, always comes from the y of your vertex. So it's at 9. Our domain is open bracket, negative infinity, comma, positive infinity, open bracket. It's a quadratic with no holes. And then our range will depend on if it's opening up or down. So I have my comma. It's opening down. That means it's going to keep pointing down. That's a negative infinity. Negative infinity is always on the left. So then on the right-hand side, the maximum value is 9. Open bracket on negative infinity, close bracket on 9. Now that we have all of our important information, we can come over here and graph it. Now if we notice our coordinates are all relatively small, so we can still count by ones, and we already have our scale over here. We need to go ahead and put our x and our y. X on the right-hand side, y on the top. Graphing our x-intercepts are at 1, 0, and then negative 5, 0. Our vertex is at negative 2, positive 9. Then I can graph my axis of symmetry. This vertical line going through the vertex all the way down. And make sure you label it as AOS x equals negative 2. Same thing we have written here. Our y-intercept is at 0, positive 5. And now we want to make sure we do the mirror. So from the y-intercept to the x-symmetry, it's 1, 2 to the left. I do 2 more to the left. The same amount of spaces between them. See how this one is 1, 2, 3, and then 1, 2, 3. They have the same amount of spaces in between them. Now that I have my 5 coordinates on here, I'm going to graph this. I always like to start with my vertex and then connect my coordinates. I know it's going to keep going down and slightly to the left. And I'm going to keep going down on this one and slightly to the right. It's not going to be absolutely perfect down here, but this is one of the reasons why we have 5 coordinates, so it's as best as possible. And then, as always, you can go back to your y equals and graph this in our calculator. So we have negative x squared minus 4x and then plus 5. We want to make sure our graph looks the same. And we said it was supposed to open down, and it does. So let's just make sure our graph looks relatively the same. It does, and we can always look back to see if our coordinates are correct. So second graph, go to your table. It's 1, 0, which was correct. And then go to negative 5, 0 is correct. Negative 2 is at 9, which is correct. And our 0, 5 is correct. And the other coordinate, our mirror, was at negative 4, positive 5, which is also correct. So these are the coordinates that we definitely want to use. You can also see there's negative 3, 8. I could have used this negative 3 and then positive 8. Same thing here with the negative 1, positive 8 to make it more accurate. I can also use negative 6, negative 7, because that's another coordinate. Negative 6 and then negative 7, it actually looks like it's going through that one. And then we would have had at 2, negative 7, which looks like it's going through that one as well. So you can always check your graph and your formula, your important information, by plugging into your calculator and just checking it. Make sure you show your work for this, but you can always check to see if you're right. This next problem, we're going to do the same thing. We're going to factor it so we can find our x-intercepts, and then we're going to use the original problem for everything else. So the first thing we want to do is factor, when we factor, is our GCF. Our smallest number is 4. So everything can be divided by 4. 8 is divisible by 4, and 12 is divisible by 4. So our GCF right now is 4. X, x, no x. So our GCF is only 4. So we write this out as 4 parentheses. Divide everything by 4. We have x squared plus 2x minus 3. Now we do our MACAB because we have 3 terms left over. So from the parentheses, we do a equals a positive 1, b equals a positive 2, and c equals a negative 3. So our MAC, MAC is 1 times negative 3, and AB is our 2. So we have 1 and 3 multiplies to 3. Now to get a 2, we have to do a negative 1 and a positive 3. So always make sure MAC adds correctly. MAC, negative 1 times 3 is negative 3. Negative 1 plus 3 is a positive 2. So this does go correctly. Now because A was 1, A is equal to 1, we do not do the box. No box method on this one. That means that we already have our factors, so we go straight into our parentheses, our factors. So we have 4 parentheses. We use the letter X. Then it's just minus 1 parentheses. Again, we use the letter X. And we have a plus 3. This is our f of x is equal to. This is now our factored form. The reason we want to do this so we can use our x-intercepts. Everything else comes from the original, but our x-intercepts have to come from our factored form. Our m is equal to a change of sign, divide, a positive 1. N is equal to, again, change the sign and divide. So a negative 3 divided by 1 is a negative 3. So our x-intercepts are at 1, 0 and negative 3, 0. Now we go back to the original problem. And again, our vertex, you can use our m and n divided by 2, m plus n divided by 2. But again, using this formula for the AOS will help you if it's not factorable, if you can't do MACAB. Got to find our axis symmetry before we find the rest of our vertex. AOS, x is equal to negative b over 2a. So we have negative, our original b value was 8, divided by 2 times our original a value was 4. So we have negative 8 divided by 2 times 4 is 8, which is equal to negative 1. So our axis of symmetry is x equals a negative 1. Our axis of symmetry is x equals negative 1. It was, you can still do 1 minus 3 is a negative 2, divided by 2 is negative 1. Same thing. Now that we have our axis of symmetry, we can find the rest of our vertex. Just writing it up here, vertex, y equals, everywhere I see an x, again, I'm going to substitute something in for it, so I'm going to put parentheses. Go back to the original, it's 4 parentheses squared plus 8 parentheses minus 12. Inside the parentheses, I'm going to put that x equals negative 1, so negative 1 inside this one, negative 1 inside that one. I can then go back to my calculator and we can plug that straight in. This is 4 parentheses, negative 1 parentheses squared, plus 8 parentheses, negative 1, close parentheses, and then minus 12. Enter. It's at negative 16. The y is equal to a negative 16. So our vertex is at negative 1, comma, negative 16. We're going to find our y-intercept. Again, from the original, if it's in standard form, it's going to be your c value. It is still 0, comma something. So if we plug 0 in, 0, 0, minus 12, negative 12. You can still plug the zeros into here and get the same thing. Our a value is equal to a positive 4. That means that it will open up. Since it opens up, you're going to have a minimum value. And that minimum value, again, comes from your vertex, which was that negative 16. Our domain is open bracket, negative infinity, comma, positive infinity, open bracket. And our range, go ahead and put your comma in there, it's opening up, so that means we're going to have a positive infinity. It's always on the right-hand side with an open bracket. And now the minimum, again, minimum, maximum, the minimum value is negative 16. Negative 16 goes with our range with a closed bracket because it stops there. We have all of our important information. Now we're going to graph it. Now, as you can see, we have some larger numbers. We have a 16 and a 12. So in this case, counting by ones is actually not going to be the best option. Even though we have a scale here by going by ones, we can change this to counting by twos so we can make sure that our graph fits. We're still going to put our x and y on here, x on the right, y on the top. But this time we're going to say we're going to count by twos. That means that this value is 2, this value is 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we can go up to 20. So our x-intercepts are at 1, 0. So again, this is 2. So we want to go here for the 1. 1, 0. And then negative 3. So this is negative 1, negative 2, negative 3. Okay, be careful about that. Our vertex is at negative 1, negative 16. So negative 1, and then negative 2, 4, 6, 8, 10, 12, 14, 16. It's right here, like in the middle of that negative 8. I'm going to put that coordinate right there. A little hard to see. I'm going to go ahead and put in the axis of symmetry. It's going through that negative 1, that x equals negative 1. It's going to go through that vertex. So we have AOS, x equals negative 1. Our y-intercept is at 0, negative 12. So 0, negative 2, 4, 6, 8, 10, 12. There's our y-intercept. And then you see how it's technically 1 away from your vertex or your axis of symmetry. We're going to go 1 away from your axis of symmetry here for the mirror image. Now, I do actually want to see, because my graph is really, really thin, I actually want to see what values would happen over here. So I'm actually going to go to a value of 1, x equals 2. I'm going to do x equals 2 and see what happens. So I plug in 2. So I'll do 4 times 2 squared plus 8 times 2 minus 12. That way I can get another coordinate. I'm going to get 20. So that means I can actually graph 2. This one is 2 because I'm counting by 2s. 20. That means that if I have see how it's 1 away from my x-intercept? I'm going to go 1 more away. So this is going to be at a -4. So if I do this, 4 times -4 squared plus 8 times -4 minus 12, because that was the one right beside our other x-intercept to the left, I should also get a positive 20, and we do. So we go to -4, positive 20. I'm getting this extra coordinate so that my graph can be as accurate as possible. You can plug in any x value and get a y value for it. You can plug in any x value and get a y. So I'm going to go connect all my coordinates. Again, the reason I did this, is because of that it's so skinny right now that I want to make sure that I can make it as accurate as possible. And then keep going on this side. Now this is curved down at the bottom. Please make sure that you're careful on that. It doesn't come to a point or a V. It does curve because it is a parabola. Okay. So if I want to check my graph, I would do 4x squared plus 8x minus 12. Now we can change our window to make it a 20 by 20. And go to my window. I want to go to a -20 on my x's, a positive 20, and then I'm going to count by 2's. Now I'll do the same thing on my y's. -20, positive 20, and we're going to count by 2's. So now we're going to graph it. And this looks very similar to our graph on the paper. And we can go to our table second graph. Look at our table. We have 1, 0. Well, there's -3 zeros, so that one's good. We have a -1, -16. We have a 0, -12, which was good. And then we had that 1, 0, which was also good. We also said it was at positive 2, 20, -4, 20. And then we also had that the mirror of our y-intercept was at -2, -12. So those are all good coordinates that we could graph. That means that our graph is accurate. So this is factoring it to get the x-intercepts, using standard form for the rest of it. And then once we have our chart, we can actually graph them and making sure we label everything on there. Labeling is also incredibly important.